Okay, I wanted to work a few more circle problems. Before we work the problems, remember all the sectors of a circle, however they're partitioned out, have to add up to 100%. That's the whole circle. And so what we're doing with circle graphs is we're trying to present information in a percentage amount that helps us see what part out of the whole somebody contributed. Okay, so let's look at that. Again, this is one piece of the pie. We would refer to it as a sector. And it tells us we would put the percentage that represents and then, something about who that is in there. Like, for instance, on problem number 2, we won't look over there, but in problem number 2, they give us a little drawing on your book on page 207, and they already tell us in the drawing that 25%, which would be a fourth, and again, I didn't draw that perfectly, but it's kind of hard to do well with this on an iPad, from 0 to 17, from ages 0 to 17, in 2007, that represented 25% of the population. That's a fourth of the circle, so I'll kind of divide the circle, kind of think about what would a fourth look like, and I'll make it look like that. We could get our compasses out. We could, get our protractors out, and we could divide it out all evenly, but we're just not going to be that specific in this unit because that's not what we're trying to learn here. We'll do stuff later with that. All right, so in number 2, it says in the year 2007, the estimated population of the U.S. was 302 million. Now, I know that's my total population, so I'm going to go ahead and call that my total population. They tell us that the age of 25% of the population was 0 to 17. So that's what I've already put in there, and they already have that in your book. 63% were 18 to 64. I'll go ahead and write the 25% were 0 to 17, okay? And then 13% were 65 or older. And if you look at this and you add all those numbers up, 65 and over, did I miss anybody? Let's see, 25%, 63%, 13%. This should add up to 100%, okay? Now, it looks to me like it doesn't quite, but that's because we're going to round some numbers to like the nearest whole number. So that's why when we add it up, it's going to add up to like 101. So we need to multiply each one of these out to make sure we get the right answers on them. But sometimes when you round, that messes up your totals. It puts it at a little over 100%, which we know can't be. But if we were really careful about going out on our decimals far enough, each one of these percentages would add up to 100% in the whole circle. So they want to know basically, well, is to finish this graph. So they've already told us 0 to 17 were, that was 25%. They're really wanting, this is kind of weird on this circle graph. They are actually want me to put in the number of degrees here, which is kind of weird. That's not usually what we do. Normally, if we were, they're kind of number 2 is being approached like, how would I mark this off? Well, 25% of a circle would be a fourth of a circle, wouldn't it? And if a whole circle is 360 degrees, that means if we were using a protractor, we'd make 90 degrees of that for 0 to 17, which is what you've seen they've done in the book. Okay. Here on this problem, they're not real clear about what they want. They could have asked us how many were of each age, but they didn't do that. So this is just a weird little problem here, and I don't understand. I guess they want the degrees here more than anything. And then, so number 1 in class, we were doing that one differently about like how much money, and we're making the percentages and putting them on. Well, here they're actually having us think about the degrees as if we were being real careful putting them on the graph. So let's look at the 63%. Here's what they're wanting you to do here, since they're really just trying to make sure you're drawing carefully with a compass and protractor, and I kind of already said we weren't going to be real careful about it. But let's go ahead and follow the instructions. What they want us to do is if we're trying to figure out how much of the circle 63% would be, we'd say a whole circle is 360 degrees. 63% would be 0.63 of that. We could multiply those two numbers, and when we do, we end up getting, you can do it on a calculator, you can do it by hand, but you're going to get 226.80 degrees. So a whole circle is 100%, but all the way around a circle is actually 360 degrees, and that's kind of how they're having us do this problem. and they weren't real specific about saying put this in degrees, and so, but that's what we're going to do here. All right, so 226.880 degrees. We're going to round that to about 227 degrees. Now, if you look up here, half the circle would be 180 degrees. So if I had drawn this circle better, half of the circle would be 180. That's more than 180, isn't it? We need to go some past 180. We need to go about 47 degrees past it. So that means that's even another, let's see, we take that, let's see, we want 47 degrees past it. That means I'm going to color in blue. You know, we're just kind of getting a general idea of how we would draw this circle graph here. This represents about 227 degrees, as best as I can do it on an iPad with a fat stylus, okay? And so that's going to represent the 18 to 64-year-olds right there, about that much of the 360 degrees. Now, the amount that's left, there's only one amount left, and that's going to be the 13% there. If you want to, you can get a compass and measure this out so that or a protractor and measure this out. Do what you feel comfortable with. Just try to eyeball it and do a good job. I would not ask you a question like this on a test or quiz anyway, just because it's kind of what I consider a strange question to ask here. Okay, let's go to number 3. So again, on this one, what they're wanting you to do is to draw the circle. And they've already put in, Emily looks about like this. I can't put a protractor on the iPad, so it's kind of hard. I'm just going to have to eyeball this. Emily, they tell us, is 43% of the whole circle. And so they tell us that, they give us that much information, and they're wanting us to fill it in for Brianna, Dana, and Jill. And so we look at what they told us. Emily received 15 votes. That's Emily. Brianna received 10 votes. Dana received 6 votes. And Jill received 4 votes. Okay, so we got to do 2 things here. Number 3 is a lot of work in some ways because you got to do several things here. And I'm going to definitely use a calculator to do all this because I can't just, if I do all the multiplication out on the iPad by hand, I'm going to have to use tons of slides here and we'll run out of time. 4 votes is Jill. Okay, so let's start with Emily. They already did it for us, but let me show you how they did that. First of all, we need to know the total votes. So let me total them up here. If I add 15 and 10, that's 25. 6 and 4 is 10 more. That's going to be a total of 35 votes. Okay. So if we're doing the part to whole that represents Emily, she has 15 out of the 35 votes. And I can reduce that down to 3/7. And if I divide that out on the calculator, it's about 0.428. We would round that to about 43% of the whole circle. Now, if I'm being real picky and I want to know exactly how many degrees of the circle is, we got the percentage, but how many degrees of the circle is that? Well, if I want to know how many degrees, that I should have drawn it off here. If I want to take my protractor and measure it very carefully, which again, remember, I cannot do on the iPad, so I cannot show you how to do that, you would have to say 360 degrees. What is 43% of 360 degrees? And that would just be 43 times 0.43 times 360, and that comes out to be about 154.8 degrees. So we're going to round that to 155 degrees. On a circle, 180 degrees would be half the circle. This isn't quite half, but it's getting kind of close. So that's why they did what they did here. I'll kind of outline Emily in red. If it had been 180, that red line would have gone straight across. So you could get a protractor and draw that if you want to, but I'm just telling you, you really just can eyeball it. That's about 155 degrees, we're going to say, because we're just really trying to focus on the typograph here, not so much measuring with our protractor. Let's look at Brianna. I'll do her in green so you can see the difference. Brianna had 10 votes. Her part to whole was 10 votes out of 25. Now, if you divide 10 divided by 25 on the calculator, you're going to get 0.4. I could have reduced that, you know, if I wanted as 100%, I could have said, ooh, I can multiply by 4 over 4 and get 40 over 100, and it's 40%. That's another way I could have done it, which is what I was trying to show you in class. But you could just say 25 divided by 10, 25 divided into 10 is 0.4. Move your decimal place over 2 spots, that's 40%. So 40% for Brianna is almost, not Brianna, I did that wrong, didn't I? Oh, I know what I did wrong. This should be a 35. Okay, let's start over on Brianna because I had the total. Her part to whole is 10 out of 35. And if we divide 35 into 10, or if you use your calculator, you're going to get 0.285, which is 20. If I move that's going to round. Let me move my decimal place over 2. That's going to be about 28.5%, and we're going to round that to 29%. Okay. Okay, I'm going to do this one, and then I'm going to have to stop because the video is going to get too long. So it's about 29%. So I could eyeball that 29%. If I want to know exactly how much that would be on this circle, I'm going to have to write over some stuff here because I don't have enough room on the page. I would say, well, the whole circle is 360 degrees. I have 29% of that, which is about 0.295. If I wanted to be really accurate, I could multiply by 0.285, but we'll just use 0.29. And that's going to, when you multiply that out, you get 104. Okay, so 104 degrees is going to represent Brianna. Again, that's not all the circle, but it's a good chunk of it. If I start here for Brianna, I'll use black. And I want to get the amount she is. She's not quite, she's 29%. She's not quite as much as Emily. Emily's 43%. A fourth of a circle would be like that, wouldn't it? That would be 25%, but it's a little bit past 25% is what 29% is. So I could write Brianna, and I could write 29% here. They really don't want you writing the degree amount there. We're just using that to kind of estimate how many degrees of the circle I should use, and if I were being really particular, I would have you get your protractor out and measure that, but we can kind of tell it's about that much. So we're just going to kind of estimate it as we draw it instead of getting real particular about using our protractor here. Just so you can check, Dana is 6 out of 35, which is 17%, so she's going to end up, let's say, about like this. And then that would leave Jill, which would be the amount left, and she's 11%. So when you do your math, probably I should make Jill's smaller here. Let me kind of outline in yellow. Dana's would probably be more like this, okay, a little bit bigger than Jill's. So we're part to whole, dividing it out, getting our decimal value, moving the decimal place over 2 places to the right to get our percentage. For instance, like here it was 43%. And then just to find the degrees, we had to say, well, 43% is the decimals 0.43 multiplied by 360, and that's what gave us the number of degrees, which is about 155 degrees there for Emily when we were trying to figure it out. If we'd want to measure it out really carefully, that would have been what we'd used there.